Okay, take two. Let's try this again. Test, test, test. 1, 2, 3, 4, 5, 6, 7. Looks good to me. All right. I don't think this ever happened before that right as I start streaming, I get a phone call. Anyway, so starting the stream a little bit early so I can get some practice in, do some warm-up exercises. Also, people kind of come in later. But we're doing Advent of Code. If you're here watching already, then congratulations. You beat everybody else. But Advent of Code, it's a pair of programming puzzles every day from December 1st to 25th. It's Christmas themed. It's been going on since 2015. We're in day 5. It unlocks it at midnight Eastern time. So for me, that's 9 p.m. Pacific time. So try to start a little bit in advance because people start filtering in. And also, if I get all of the nervousness out and I get some practice in before the actual puzzle starts. Hey there, Meme Clear Bams. How are you doing? Okay, so let's practice a little bit using 2016. So we're going to be doing day 5 in 2016. So let's get set up on that. Yeah, and if you haven't been able to tell, I'm doing this year, just like last year, it's all in Rust. Because I'm a fan. What can I say? So, in the lib here, we'll import a module for day 5. Pull in the day 5, part 1 and part 2. I'm going to copy day 4 to day 5. And we're going to just drop everything that isn't part of the scaffolding, so to speak. So replace that with to do. Place that with to do. Okay. Oh, that's right. Part 2 of the last of what was that? Day 4 had a different way to test it. Okay. Hey there, 715209. How are you doing? Yeah, so once again, we're going to be doing day 5, but it doesn't unlock for another 35 minutes. So I'm practicing by going back in time to 2016, day 5. So, how about a nice game of chess? You are faced with a security guard designed by Easter Egg Bunny engineers. So it must be, oh, security door. I thought it said guard. So, okay, the door is designed by Easter Bunny engineers that seem to have acquired most of their security knowledge by watching hacking movies. Hey there, TS Just. You're doing 2015? Cool. Your numbers? Yes. 715209 is indeed a number. The 8-character password for each door, or for the door, is generated 1 character at a time by finding the MD5 hash of some door ID, your puzzle input, and an increasing integer index, starting with 0. A hash indicates the next character in the password. If its hexadecimal representation starts with 5 zeros, if it does, the 6th character in the hash is the next character of the password. For example, if the door ID is ABC, the first index which produces a hash that starts with 5 zeros is 3231929, which we find by hashing ABC 3231929. The 6th character of the hash, and thus the first character of the password is 1. Okay, it's already I'm already lost. Starts with 5 zeros. Wait, there's no 0, 0. So I'm missing. I'm already confused. Good. I'm going to get all the confusion out before this year's day 5 starts. Such Bitcoin, much hashing. I know. My phone keeps triggering. I don't know why. shut the phone up. Okay. Sorry. So we're getting all the kinks out of the stream before we actually get into the real day 5. You need to find a hash that starts with 5 zeros. The 6 characters, then one of the... I know I keep reading that, but it's not sinking in. The first index, what does this mean? Which produces a hash that starts with 5 zeros, is that. Where does this come from? Which we find by hashing that. Okay, maybe this would help if I started over. Okay, it's the hash of the door ID and an increasing integer index. Okay, I get it. So we're supposed to take the door ID and then append to it a number, starting with 0. And we would keep going until we find, oh, when we hash that, we get this hash code. I get it. The 6th character of the hash. So what is this? What did they say? The 6th character of the hash. I guess it's not showing the hash. But the 6th character is 1. I don't get it. Anyway, 5017308 produces the next interesting hash, which starts with, so yeah, the 8. Okay, I got it. So it's 1, 8. Okay, they're confusing me by not showing the hash in this paragraph, but they're showing me the hash here of the 2nd digit, and there's an 8. I get it. So we just keep going through until we find that. I got it. 6th character of the resulting hash. Yeah, but like these instructions are confusing because here they don't say what the hash is. They just say, oh, we're not going to tell you what the hash is, but the 6th character is a 1. Here they show me the hash, and I can see the 6th character is an 8. First time a hash starts with 5 zeros is for that number. Discovering the character F. Oh, the third time. I didn't read it right. In this example, after continuing the search a total 8 times, the password is that. Given the actual door ID, what is the password? Why is it giving me the puzzle input right away? Don't I usually need to click something? Anyway, here is the door ID, which is the input. And then that's the output. Okay, so hold on. Is MD5 in the standard library, or do I have to use Ring? I guess I do have to use Ring, so Ring, right? Crypto library. Actually, I guess we could probably find an MD5 small one. That's okay. We can use Ring. I know Ring. ND5. Oh, Ring doesn't have ND5. It has SHA though. Okay, fine. Ring doesn't have it. Probably because it's not secure anymore. Which one? Which one? They both have a lot of downloads. That's weird that there are 2 of them. Of course, it's got a security warning. Why are there 2 of them? Pure Rust implementation. I don't know. Almost literally the Bitcoin algorithm? Yeah, the wording is weird. I'm stuck on picking a package. Actually, I guess we'll just pick ND5 because there shouldn't be a dash in there, so it must be wrong, right? So we need ND5 version 0.7. All right. Should we just do the brute force solution? Keep hitting the wrong keys. So a loop, let output equal, we'll just start with this, we'll just have a vector. Actually, then why don't we just make this a while? Output.len. We need to go until we get how many characters? 8. Const password length use size equals 8. while it's less than that. Oh, and we'll want to have the, what do they call it? Increasing, they call it an index. Let mute index equals 0. Okay, so then let hash equal, and let's see, how do we use MD5? MD5 compute. Easy enough. And it takes like a bit stream. Okay, so then let data equal input to owned plus index to string dot, actually we'll just leave it as a string. We just say for this as bytes, and we get a digest. Okay, now what do I do with the digest? Format it as hexadecimal. So then format. Yep. And then it's if hash first 6 characters, right? Five characters. If the 6th character, okay. So const hash match zeros is 5. Actually, what if we just make this a string like that? If hash dot strip prefix hash match, if let some suffix, so if it matches that prefix, right? Then output dot push suffix 0, or suffix chars next unwrap, basically. And then at the end it's just output collect. Well, actually I guess this could be a string. You can you push onto the end of a string? Yes, you can. What? Okay, I guess we borrow something we constructed on the fly. Expected bool found unit. Oh, let. See, I'm rusty. Ha ha ha. No pun intended. Hey there, Sarian. Got distracted while writing a data flow analyzer. Yeah, 8OC, that's right. But you got 25 minutes before it actually starts. We're practicing on 2016. Right, it needs to be mutable. And then I need to remember to increment the index. I guess technically we don't need a semicolon for that last line. Let's see if we got it right. Don't know. It's just very slow. I don't know if it's looping forever. So let's say whenever we find a digit, and then we'll say if index modulo I don't know, 10,000 equals 0, printf print line index. I probably did something wrong. Because we should have hit a digit by now. Actually, we won't until we get to 3 million, so it's just too slow. That's what it is. Actually, it won't take that long to get to 3 million, so I could just kind of wait it out. While I do that, maybe consider how I could make this faster. Without knowing the hashing algorithm, I don't know if I can make it faster without, let's see, we got that first character, but this is going to be way too slow. The character is correct, too. Okay, I could just try the release build. Let's have it print every 100,000. And, is it cargo test release? Oh, I have to be in the 2016 folder. How do I identify the test, though? That's how I do it. Day 5, test part 1. Something tells me it's not working. No, it did work. It just... when I scrolled away, it told me I passed the test. Okay, well, this seems brute force to me. Let's just try it. So, if the... Actually, we can just put it in here. Cargo run release 5-1, right? We're unlocking the password character by character right now. Okay. Got a gold star, but I don't feel good about it. It's so slow. Not paying attention, but you should probably use a bit mask to test for the leading zeros. My bit mask is strip prefix. Think AOC is getting too hard day by day? Well, this is 2016. And yeah, now I'm doing a release build. It wasn't before. This one takes multiple seconds to complete. But I guess I'm used to 2020 where most of the puzzles could complete within milliseconds. The fact that this one took seconds is making me think that I'm not doing the most efficient way. Let's just continue to part 2. As the door slides open, you are presented with a second door that uses a slightly more inspired security mechanism, clearly unimpressed by the last version. In what movie is the password decrypted in order? The Easter Bunny engineers worked out a better solution. Instead of simply filling in the password from left to right, the hash now also indicates the position within the password to fill. You still look for hashes that begin with 5 zeros. However, now the 6th character represents the position, and the 7th character is the character put in that position. A hash of 1F means that the F is the second character, right, because we start at 0. Use only the first result for each position. Ignore invalid positions. Okay. So, once again, the door ID of ABC goes here. Would get me this. Okay, so we're going to modify our algorithm a little bit. Is the input different? So I guess the actual door ID didn't change? Yeah, it's still that. Okay. Just checking. I could feel all the mistakes leaving me. Now I'll be really set for 2021 day 5. So instead of pushing that, and instead of having a string that we fill in from left to right, I really do need I think I'm going to choose a hash map. And we'll have it indexed by the position, and then we'll know if we already found a character in that position, and we can ignore it like it says to do, right? Use only the first result. And also we can ignore invalid positions. Is just we'll check to see if it's in the range of password length. Yeah, okay, so we'll do that. Gonna need to import the hash map collection. So this will be if let, can't spell, if let, can't remember the type name. Vacant entry equal output dot entry of this. Well, we'll say, actually I need to get 2 characters off of this, right? So then let the digit equal suffix, well, let's grab the suffix chars. Let chars equal suffix chars, right? And this needs to be mutable because we're going to call next twice. Chars next unwrap, and then let position equal chars next unwrap. And then we'll need to convert that back to a number. So we need to say as U32 and then subtract whatever 0 is as a U32. And then let's get the result as a use size so I can compare it with password length, because we're going to skip it if it's greater than, right? Yeah, so if position is less than password length, I'm going to do the rest of this. If let vacant entry equals output entry of digit, no, position, then entry dot insert. Okay, the red lines are really screwing with me. It's insert with, right? Okay, why does it not like this? It's really confused. Hash map. At least I got that type name right. Is it or insert with? I can't remember. What can I do with a vacant entry? It's just insert. Okay, I have to do this without IntelliSense for a little bit. How does insert work? We just put the value in there, so it would be digit. Expected tuple or tuple. Is it tuple or tuple, chat? Oh, I need to put in entry vacant in front, right? And then vacant entry. And that needs to be imported from hash map. Did I do this right? What this is? Oh, it's a struct, not an enum. So it's just entry. Yeah, okay. Pretty bad at doing that by hand. Okay, anyway, so we get the digit, we get the position. Then if it's in range and the entry in the map is vacant, we insert the digit. We should probably have a count. Let mute digits left equal password length. And then we'll say while digits left is greater than 0, and then if we get one in here, we'll decrement it. Digits left minus equal 1. And then add 1 and print that just so we can see progress. And then we're going to want to sort the digits by their position. So let digits Well, we can just convert it, right? Let output equal output dot into iter dot collect vector, I guess. Now you get a vector of positions and characters, and then we can just sort it. So output dot unstable, sort unstable. Weird that it just closed that on me. Oh, it's unstable by, that's why. Comparator. So comparator function takes an A and a B. And we're gonna want to say A dot 0 compare B dot 0, right? And borrow the B 0. And then it's going to be output dot into iter map position and digit to just digit, and then collect as a string. And we don't need the position anymore. I think I got it. Was there another condition on the puzzle? Okay, and I got 12 minutes left before the real deal starts. Okay, let's just see it run. Part 2. So are my print lines not working when I run a test? Is that why I'm not seeing anything? If I just run this debug build, what's the first one that we should get? Oh, right. So when we get to 3,200,000. Okay, so it didn't even work. Unless, did I forget to print something? I did. I did in the first one. So I guess we'll just debug. Print line isn't working when I run release build. Does ePrint line work? Let's just print the entire output here when that happens. Oh, and I want that to be an ePrint line. Always said it the second way, but apparently it's the first. Tuple, tuple, double double. But others made that I'm not seeing ePrint lines when I run the test. There's got to be a way to see the output, and it's an option probably to cargo test, and I just don't remember what it is. And I just don't feel like looking it up. I guess I should just look it up while I'm waiting. So let's go to DuckDuckGo and say cargo test print line. Why doesn't print line work in unit tests? Blah blah blah. It happens because so you have to do the no capture. Okay, we can do this no capture. No capture one word. Yeah. Wasn't expected or isn't valid in this context. Okay. Oh, and with the dash dash. So at the end, I guess. Yeah, there we go. Still seems rather slow. Okay, so there we're getting 5 goes into 1. Is that right? 5 goes into position 1. I think I got it backwards, actually. Yeah, I have them backwards. That's a problem. So let's fix that. That's the position. That's the digit. Try again. Oh, hold on. I just need to reverse those, the order in which I get them. So position 1 is a 5. Okay. So it's building it. What do we get to? 1, 2, 3, 4, 5, 6 digits. Okay, got it. And the answer passed. Okay, good. So then let's just run it. Run with release 5.2. I don't know, for some reason I don't like this 2016 day 5. It's building it. It's getting there. What are we up to now? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6 digits. 7. 1, 2, 3, 4, 5, 6, 7. And the 8th one, oh, we got it. Submit. All right, we did it. Just brute forcing something with no easy way to improve it feels very unsatisfying. Yeah, that's what I was saying. I mean, is there some, like, knowledge of MD5 that, this MD5 compute, that if we knew more about it, we could, like, I don't know, skip even numbers or some jazz like that? I don't know. I don't know. It doesn't feel right. This was very early. Yeah, that's true. So each year is getting better. Is that the premise? It didn't need vacant entry. So I got like 5 minutes. Clean this up a little bit, I guess. I suppose we don't really need to print that out. Yeah, I guess that was just because I was worried it was taking forever. So I can remove the debugging. Can't see where it is. Oh, here it is. Oh, did I have the benches set up? I did. So I could benchmark this. Looks like I didn't bother to bench days 3 or 4, but we'll bench day 5. Okay, so cargo bench 5.1. Yeah, I wonder how long it'll take for Criterion to bench it, because it expects to be testing something that, yeah. So it's going to take over, what, 15 minutes? It's collecting 100 samples, so let's reduce the sample count. There's a way to do that, right? Oh, shoot, I had it in the history. For this file, in fact. Here it is, slow Criterion. I want that, and I want to put it in this function right there. So this is the slow group. Sample size, we'll just make it 1. And then we'll bench 5.1 and 5.2 with just 1 sample. Because that's just because I want to get the amount of time. I don't want to wait forever. Okay, you didn't like it? It has to be at least 10? Okay, fine. I don't have that long to wait, though. I only have like 3.5 minutes. I guess I could time it myself. You stopped making MD5 base puzzles after that year? This is going to take over a minute to run 10 samples. I got over a minute to waste. I mean, use. Actually, let's just, while it's running, I'll just set up 2021 day 5. So copy day 4 to day 5. In lib, we'll make a mod for day 5. And we'll bring in day 5, parts 1 and 2. And in the main, we'll make it so we can run parts 1 and 2 from day 5 from the main. And then let's clear this out. We did bingo yesterday. That was fun. I even made an iterator. Fun times. Okay, this is all to do. All right. Still benching? Gonna run out of time. Okay, there we go. So 7.6 seconds. I don't think I have enough time to bench part 2. Can we get an estimate by how long it says it'll take? Probably, right? Because they just divide it by 10. Let me guess. It's going to be like 15 to 20 seconds. Which we'll know in about 15 or 20 seconds from when it started. Minute and a half to go. Ooh, 26.17 seconds. Okay, so anybody else who has a solution for 2016 day 5, let me know if your part 1 goes faster than 7.5 seconds and your part 2 goes faster than 26.17 seconds. And then I'd be curious to know. But anyway, we're going to go to the current year. We have 1 minute to go. And I guess we'll just clear out our tests so that we don't waste time doing that. And clear that out. Clear that out. Oh, I have an extra function. Let's clear that out. Make sure it builds. Okay, it should build. All right. Take a drink of water. Anybody else is doing it, good luck. You can do these puzzles in any programming language. You get 2 puzzles every day from December 1st to 25th. It's all Christmas themed, so it's going to be silly. Good luck, everybody. I think TS Jost is a little bit faster than me on the leaderboard. Shows him ahead of me. I don't mind. It's all good fun. I'm not a speed coder. Speed coders will be done in about 7 minutes. That's my guess today. It'll take them 7 minutes, and it'll take me probably half an hour. Here we go. Hydrothermal venture. You come across a field of hydrothermal vents on the ocean floor. These vents constantly produce large opaque clouds, so it would be best to avoid them if possible. They tend to... done already? I see. They tend to form in lines. The submarine helpfully provides a list of nearby lines of vents, your puzzle input, for you to review. For example, 0959. Each line of vents is given as a line segment in the form of XY to XY. So this is a line from 0, 1, 2, 3, 4 to 5. Okay. These line segments including the points at both ends. So this would be a line of 6. And this is a diagonal line of some kind. I see. So are they all like either horizontal or diagonal? This one is not. Oh no, it is. It's 4 or 5 long, right? Okay, so they're all like left to right, or they're all horizontal, vertical, or diagonal. So let's grab this example because that's going to be our test input for part 1. Go down the line here. Only consider horizontal and vertical lines. Okay. Probably part 2 will be considering diagonal ones, right? So here's a diagram of it. Okay, so each number is how many times that has been crossed. To avoid the most dangerous areas, you need to determine the number of points where at least 2 lines overlap. In the example, this is anywhere in the diagram with a 2 or larger, a total of 5 points. 1, 2, 3, 4, 5. Why is that one twice? Is there a singleton in there? 0, 1, 2, 3. 0, 1, 2, 3, 4. 3, 4 somewhere? Well, there's the line from 3,4 to 1,4. Oh, it's where the ends met. That with that. And this one was just, it overlapped, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This one overlapped with that one. Got it. How many points at least? Okay, so the answer here was 5. Okay, easy enough. I think we'll just make a grid. So let grid, immutable grid. Actually, I don't even need a grid. We're going to have points is a hash map new. And I'm going to make a type for the coordinates. So struct coord x is usize, y is a usize. And we'll want to implement partial equal, no, hash. And I think hash requires them to have partial equal, right? Anyway, to do. Hey there, Phoenix. Hash map is from collections. And why does it say I can't make one? Because it doesn't know the type. I guess we'll just put in the type for now. It's going to go from a coordinate to a usize. This is where I need to probably fix this, right? This goes there. Oh, all I need to do is derive hash. See, if I didn't do that, it'll complain about this probably. Oh, it didn't complain. Oh, because I haven't tried to use it yet. I'll probably need that though. Anyway, we're going to take our input and break it into lines. Yeah, so input.lines dot, I guess, split it at the arrow. So map line, line dot split once. Aren't you suggesting something? I don't know what it's doing. Okay, the delimiter is arrow. And then unwrap. So let start and end equal that. And so then we're going to take the start and the end and split those twice again to get the x and y coordinates. So I'll make a function to do that. Let start equal 2 chords start and end. And I just put the function here for now. 2 chords. It's input string output chord. So it's going to be input, well, let x and y equal input dot split once. The delimiter is a comma. Unwrap that. Let x, well, we can just say chord at this point. X is x dot parse dot unwrap. Same thing for y. All right, and then we have coordinates for start and end. So then I can just walk from one to the other, but we need to know the direction. So the direction, okay, then to make this easier on myself, I'll change this to I size, because then we'll just take the direction as being the difference in coordinates between the start and the end. So let dy equal end y minus start y. And let dx equal end x minus start x. And they said to ignore the diagonals, so it's going to be only if dx equals 0 or dy equals 0 do we use this line. And why are we getting all these warnings? I don't know. Oh, because we didn't evaluate it. So I actually don't need to evaluate it. So I'll just say for line in to make this easier on myself. Get rid of that. Yeah, those warnings distract me. Okay, so then we're gonna basically walk from start to end, going using dx and dy. I think I just want to divide to get the sign of it. So we'll say let direction x equal dx divided by the dx dot absolute value. Let dir y equal dx divided by dy dot absolute value. And then for well, dung bug. See, TS Joster's much better than I am. Also, I'm talking, so it slows me down. This is how I make myself feel better about being slow. Let me think about this. So I could do the that's the vertical case or the horizontal case separately, but I'm trying to be smart and doing them simultaneously, and this might be tripping me up. I do get a direction. One of these will be +1 or -1. I guess I just want to I want to have the start and then just keep moving until we get to the end. So why don't I just do that? I'll just say while start is not equal to end, and then I'll just say points dot entry borrow start. Can't remember if you borrow it or not, but anyway, it's or insert I guess or default. That'll work. Plus equal 1, right? I just need to have a the default for usize is 0. Can't compare them until I actually derive equal and partial equal, which I can do. And yeah, entry's going to say I need hash, right? Yeah, there's where I need the hash. And yeah, I need to dereference that. And I guess this has to consume it, so it's going to need to be a copy type as well. All right. And we want to say start, well, let's just say let mutable position equals start, and then we don't need to make start mutable. We'll just use position. And we'll say position.x plus equals direction x. Position.y plus equals direction y. And eventually it'll hit the end and break out. And then after we get to the end, we really just want to say points.iter, well, into iter, dot filter map, and we'll have a tuple, right? Coordinate and count. I'm not going to need the coordinates, so I'll just ignore it. And it'll be after we filter everything out, we're going to want to count them and then to string to get the answer. So the condition is if count is greater than 1, then we're going to return true. So I guess it's just count greater than 1, right? And no semicolon there. And it doesn't let me copy because I need to have clone if I do copy. Fair enough. Count greater than 1 won't work because expected an option. Oh, shoot. Let's just do filter then. It's easier that way. And I have to borrow because, okay, I don't have to borrow. I can dereference count. All these things I have to do. And this is position, not start. All right, ready to test? Failed. How did it fail? Oh, we got a panic. Invalid digit on line 15. Oh, I forgot to trim. So let's just do it here. Trim before we parse. Try that again. I made that mistake a couple days ago too. Maybe it was yesterday. Divide by 0. Where did I divide? 33. Oh yeah. Okay, if it's 0, we can't do that. Shoot. So it would be if dx is 0, 0, else divide. I should have done it for both lines at the same time. It's probably an easier way to do this, but I'm stressed for time. Run that test again. Still failed. We only counted 2 instead of 5. Okay, well, let's look for a bug or debug? Let's debug the positions that we're tracking. Run. It can't compile because it can't be debugged, so we can make it debug. Run again. All right, so 0, 9, 1, 9, 2, 9, 3, 9, 4, 4, 9. Oh, we didn't hit the end. Okay, I messed up. So we have to include the end point. So this should be loop. And then if here, then break. That's probably what it was. It didn't include the end point. It went up to the end but didn't include it. Okay, so now we're passing the test. So then remove the debug and get my actual puzzle input. Here it is. Make a new file called 5.txt. Paste the text in there. Close it up. Make sure it says 5.txt at the top and cargo run 5-1. And compute. Oh, I'm in the wrong directory. I'm like, why is this taking so long? It's 2021. 5,690. Yay! On to part 2. Off by 1. Yeah, of course I was off by 1. Unfortunately, considering only the horizontal vertical line, of course we're going to have to do diagonal. Because of the limits of the hydrothermal event mapping system, the lines in your list will only ever be horizontal vertical, or we already knew that. So considering all of them, it's that. You still need to determine the number of points. This is anywhere from... Okay, well, so if it's the same, I think we can do this part really fast. Right? It's this again. Slowing me down is this part. What was the number? 12. Me wanting to line this up is going to slow me down by a few seconds. Anyway, it's the same algorithm, only we take out a condition, right? We take out this one. We just do this always. Isn't that it? And I just run this again and I'll get the right answer? Yeah, that was easy. So run 5-2. 17,741. Easy. That was the fastest I've done a part 2 ever, I think. So I see leaderboard, personal stats. Ooh, look at that. Sub 1,000. I love it. That's very rare for me. You can see I usually get in the 2,000 to 3,000, but I got sub 1,000. Up my game and maybe I'll get some score. To get a score, you have to be the top 100, by the way. So I did it in 15 minutes. What do the real speed coders do it in? 3 minutes. Wow. So wait a minute. Shouldn't this guy who got it in 1:42, shouldn't he have gotten it like a few seconds later when he knew the part 2 would just be add the diagonals? But it took him a full minute and a half later? That doesn't make sense. 3 minutes and 26 seconds. 1 minute and 42. So it took him like another minute, almost another 2 minutes to figure out just add the diagonals. What's going on there? Look at this solution. Why? Why am I looking at this solution? It's his solution. Okay. Well, why did it take him so long to do part 2? Part 2 is the same as part 1, only you handle the diagonals. Oh, okay. So I see. Part 1, he made a big assumption that he could just pick a direction based off of which one is a greater differential. But for diagonal, that's not true. So that screwed him up. Okay, that's why. See, he could have been number 1 if his part 1 handled diagonals, but he just disabled it like I did. Right? Because he was so fast on part 1. He was like a good 16 seconds faster. He could have totally won. That's cool, though. He did it in Rust, though. So, what can I learn from his solution? Probably that there are a bunch of clever little things that I could have done that he did. So, he had the same split as I did. And then the 2 chords he did in a single line, which I kind of did, only I ended up doing... I probably wasted a lot of time by having this chord structure, right? He used range min and max with a +1. Interesting. That's pretty clever. He did the same kind of thing, though, right? His grid is a... Oh, that's not Rust. It looked like Rust to me, but it's actually Python. But anyway, he used the same kind of data structure. His grid was a dictionary, and mine's a hash map, same thing. And he did the same kind of thing for when it was counting. So you iterate through the values, and anything that's greater than 1, you count, which is what I did. Okay, so I don't feel too bad. He just had a more clever way of doing the walking. I figured out the direction in both dimensions, and then I had this holding back and from doing the diagonals. I then taking the distance, I turned it into a direction by dividing by the absolute value, and then I screwed up because I didn't handle 0, but whatever. And then I had the same kind of walking he did, where you just get it and with the default being 0, and then add 1, and yeah. So he just had a more clever version of walking it. That's cool, though. You speed ran for vertical and horizontal, and now you can't think of how to do the diagonal at all. So for me, since I get the basically the vector from start to end, the vector points the direction you want to go, right? So you just take its basically what this is doing is this is getting you a vector, this is getting you the normal of the vector, and then this is just walking by the normal of the vector until you get to the end. So if your solution didn't involve calculating the vector from start to end, I can see why you'd have a problem. But if you do it with the vector to start with, it doesn't matter which direction. This would even work with a non-diagonal. It's just that I would have trouble with if it was like 30 degrees, then this direction wouldn't work, because it wouldn't be a normal. I made a big assumption here that I can just divide by the absolute value of one of the of each dimension to get a normal. I'd have to be a little bit more clever with my normal, and then we have to ask ourselves, what do we do when we're falling between grid points? Other puzzles in past years did handle that, right? They would give a rule like it stays in the same, you would round up or down to find out which grid cell you're in. You're doing vector math, you're still getting the wrong thing. Are you normalizing your vector to get a direction? Maybe you're not doing that. Or maybe the way you calculated the normal wasn't right. I didn't check for 0, and so I had a divide by 0 error. But yeah, my part 2 is the same as part 1 because I had the vector approach. Anyway, that was fun. So Escape, do you know hyperneutrino? Are you hyperneutrino? You don't have to say if you are. I'm curious to know who the top Rust person is. Bataveros is always winning. Let's see what Bataveros' language of choice today is. Does he even have it checked in? Maybe not. Private. We can't see what it is. Well, he does have something in Rust. See, they have GitHubs, but they're not posting their solutions. Pity. Anyway, I guess that's it. I've only been streaming for like an hour, though. I kind of feel like, you know, once I got the energy going, I want to keep going. So I can go back and, well, a couple choices. I can go clean up my solution here. We can try to think of a clever way to do it. I don't want to steal from the speedrunner, though. I want to just see if I can think of a clean way to do this. There must be a much better way to normalize the vector than that, right? Let me see if I can think of what it would be. I'm thinking if we get the Manhattan distance, maybe, and divide by the Manhattan distance, we would also get... So, yeah, we could let the distance equal dx plus dy, and then we can just divide by that. That would be a little bit more... I don't have to have this if-else, right? I can just say dy divided by distance. That should work for horizontal and vertical. Yeah. Maybe not. Why is it taking so long? I screwed it up. Abort! What did I do wrong here? Oh, Manhattan distance is the sum of the absolute values. So it was walking off into the abyss, right? So sum the absolute values to get the distance. Yeah, okay, that was it. All right, so that's a little cleaner. But we can't do that when we might be walking a diagonal because it'll be doubled if it's a diagonal. But if we know that it's doubled... Okay, here's a little trick we can do. We can do the same kind of thing, but we know it's a diagonal if they're both non-zero. So I can say, what? Oh, this. We can do this. But I can take this, whoops, wrong key. I can take this quantity, and I know I will need to divide by 2 if it's a diagonal. So I will divide by, and we'll just have a test if it's diagonal. If dx is 0 or dy is 0, then it's 1. Else, it's 2. That should correct for the diagonal problem, right? There we go. So that's a little bit better, because I don't have to have as many lines of code. You don't think that's the same as normalizing a vector's Euclidean distance? It's not, but I'm cheating because I know that the direction is either horizontal, vertical, or diagonal. And this is a really hacky cheat, right? This means if it's horizontal or vertical, then we know we can add the Manhattan distance is the length of the vector by definition. If it's a diagonal, we know that the Manhattan distance is twice the length of the vector by definition, right? Now, any other angle is not going to work, of course. So yeah, I'm totally cheating, sort of, like by knowing that the input is always going to be exactly along a basis vector or exactly diagonal on it. You want to divide by square root? No. This is, think about it. So like, the Manhattan distance is like if it's up 3 and to the right 3, then when we walk diagonal, we actually don't walk a unit of 1. We actually walk a unit of square root of 2. So that square root of 2 factor is already factored in, so to speak, right? Go back to day 5. Like, when you go up or down or left or right, you're going 1 unit. But in part 2, they don't go 1 unit. They go a square root of 2 unit when they go diagonal. See how that works? So factor is already included there. And it's divide by 2 because if you, like, let's say we go from this 2 to down to this 1, we're moving from here, we go 1, 2, 3, 4, but it's actually only 2 steps of square root of 2. So I can take the Manhattan distance, divide by 2, and it's the correct distance. So it's just a bunch of cheats knowing the rules of the puzzle. Totally wouldn't work if we weren't stuck on a grid and the movement was always 1 unit and not a square root of 2 unit on a diagonal. Hopefully that makes sense. It's sort of cheating, and it's sort of hard to wrap your brain around it if you're used to doing this kind of stuff in Euclidean space, because this is like, you know, not moving at the same pace as a horizontal or vertical at all. And okay, anything else I can clean up here? I could get rid of this check here because we know the distance. I can just say for blank in 0, and then we can actually do that kind of. And then I don't need this check, right? Not dist. I can do that. That should still give me the right answer. Let me double check. This is why we have tests. Yeah. So can I do the same thing here? Yes, I can. I can just say for don't care what the loop variable is in 0, include the distance. Then I can get rid of this. What else can I do besides test to make sure I didn't break it? I mean, the usual things would be to refactor this all into another function. I don't know. I don't mind doing all these unwraps and parses and trims because it's, even though it's sloppy, this is for just getting the answer to a puzzle. It doesn't need to be production level stuff, right? So I don't care about that. Just stopping to think, is there an even more clever or compact way to do that? And I can't think of any. How would we make this completely functional? Like remove all the semicolons? Because Musen's doing that. How would he do this? I think because we're accumulating state, we would do this in the form of a fold. And at the end, we would take the result of the fold and chain it with that, right? So let's see if I can do this without any semicolons. It's going to be hard because of this stuff. Shoot. What am I getting myself into? So if I wanted to turn this into a function chain, it would be this and then a fold, right? And here's where we would put this hash map new. And then we would get the points which we'd want to mutate. And then we'd be given a line. And we do the rest of the work here, right? And at the end, we would have that points, so we would just do into iter filter. Okay, there we go. The trick is this stuff like this. Oh, at the end I need to return points. right? Okay, so we got rid of a couple semicolons, and it's starting to look like a function chain, but the interior of this fold needs to be fixed. So how do we do that? I think we would operate on the option. How would we turn this into a function chain? It would be getting rid of these variables start and end, but how would I do that? Wish Musin was here to tell me what he would do. We get an option out. Functionally, what would we do? I guess we would maybe need to make a function that does all this stuff and spits out the points, right? So I guess we can try that. So let's name this function the spirit of the puzzle. It was vents, right? So like mark vents. And we would have the points there, and then hold on, this is messing up. Okay, so this is a tuple having two slices in it. Okay, so it would be start, end, and then colon, and then like this, right? I think. And then the output of that would be points. Actually, we can just move it in and move it out. Like so. Make sure the syntax is right so far. Maybe you should map before fold until you get left x, left y, right x, right y, just a random thought. Problem is split once gives me an option. Oh, right, you can map an option. So I can map that option to coordinates. That's a good idea. So before the unwrap, I can map. I will get start and end as slices. Yeah, that's a good idea. So it would be map that to another tuple, which is just running it through two chords. Like that, right? Missing some syntax here. What am I missing? I'm missing this parentheses there. Okay, cool. So then instead of this taking slices, we already have the chords. So that's getting us a little further. You would even do that above fold as you get the lines. I see what you're saying. So just before folding, do all of the conversion first. Does it really matter? I guess so, because the goal would be to try to put all the functions to the left, right? Grumbles about missing obvious case in part 2. I'm sorry, Sarian. Sarian, I know you were probably busy solving it. Did you see my score? Did you see my score? Look at that. I got less than 1,000. Woohoo! You would get rid of some. That's what we're trying to do. We're trying to get rid of semicolons. This doesn't have semicolons yet. Well, I mean, I'm not done. That's our next semicolon. You're just saying, and I agree with you, that we should try to do this stuff outside. My first goal should be getting rid of semicolons, though, right? I think we'll get rid of semicolons, and then we'll try to push all the functions outside as much as we can. So yeah, can't I just it's kind of cheating, but can I just map this thing all the way through and then unwrap at the end? Hold on. We don't need to do this anymore. I see how I could just one way. It seems cheating, but I can just continue to map and each time accumulate a bigger structure. So we start with a structure that has 2 coordinates. We could then map it into a structure with coordinates and the direction vector, and then map that to the coordinates and the distance, or the normalized vector and the distance, and then map that into well, we could then fold that into the hash map with this, which actually leads me to think that I should move this out, but we can do that at the end. That's where you were starting to go. The case you missed was so obvious that part 1 restricted you to it. Yeah, when I was reading part 1's instructions, I'm like, oh, they're purposely leaving out the diagonals. I know what they're going to do for part 2. So I purposefully, I don't know if I did it, actually I don't know if I did it purposefully or not, but as I was writing part 1, I'm like, oh, here's where I would take out the if we wanted to handle diagonal, but I have to put the if there because we want to exclude diagonal. And sure enough, I'm like, sweet. So I got like part 2 in like, I don't know, under a minute after part 1. That was the best. Okay, yeah, so let's, I don't know if this is cheating or not, but we can, let's just define structures for each part along the way here, right? So we'll have a struct chords, which is start is a chord and end is a chord. And then we can just turn this into chords, start and end. Did I do that right? It doesn't like, oh, probably because of that. Chords. Yeah, so that's one thing. So it'll be just easier to deal with. So then after that, we would then map. Why don't I just make a function like to what are we going to call the next thing? The next thing would be something that has the coordinates in it. And then also the if we need to filter that out, I'll need to use filter, so I'll need to have these calculated first. So that's it, right? So it's what is the thing called though? I guess direction? No, it's not direction. It's like, we'll just call it delta. And I can actually use a chord for that, right? And we'll just say chords with delta. Sure. So then we're going to map 2 chords with delta. And put that where? Here? So we're given chords. And then that outputs chords with delta. And in there we'll do this little bit. So it's chords with delta, chords, and chord. X is end, oh, chords dot n.x minus chords.start.x, and y is chords end y minus chords start y. Like that, right? And this is delta. Right. So then it's chords with delta. So the next step after that would be to filter chords. Well, I wish I had a better name other than chords with delta. We want to filter out chords with delta dot x is equal to 0 or y equals 0, right? And we still have chords with delta, but we've taken care of all this stuff. So then after filtering, we want to map. So I could just turn this into a map, but we'll do it step by step. I want to map it to now chords with direction and distance. To chords with direction and distance. Absurdly long name. I need like another name for it. So chords with delta. Chords with direction and distance. Inventing these incredibly long names as we go. Chords. And the distance is going to be this. So that's chords dot, chords with delta dot x and y. Comma. And then the direction. So let's just copy that into here. So the direction, we'll just make it another chords because we can. A chord. X is this quantity divided by this. Ooh. Maybe you need to break this up because I don't want a semicolon. Right? Okay. So we'll do it another step. This is probably a horrible way to do it. With direction, right? If we just, no, with distance. Chords with distance. Just that part of it. And then we'll have this come in with its delta and distance. That's ridiculous. This is ridiculous. So this is already calculated then. Distance. And then the direction is then this part. Okay, I just need to define these. This is, again, this is ridiculous. Yeah, dot equals is inclusive. Yeah. I think I called that when I was first learning it, I called it the tank operator. Because the dot is like the treads and the equals is the cannon in front. Okay, delta is a chord and a distance is a I size, right? And then this other massive type, oh, I just call it dist. Oh, I need to have the delta in here. I'll keep it dist isize. All right, now this ridiculously long structure name. Chords and direction and distance. So it's kind of like this, only we have a direction. But it's the same type, so maybe I can collapse this two in a minute. Okay, the distance is this one. Yeah, the names are too long. So first map it to that, then map it chords to this. Getting there. So now we have coordinates with the direction and distance. Right? Okay. So yeah, here's where I really want to do the fold, because I want to want to reduce this loop into a fold. So I need to like I need to get this as an iterator out. Well, what if we're able to just turn this thing up here into an iterator of coordinates? Yeah, why not? So, let's invent something called, these are called vents, right? That's what I've been calling them. Yeah, vents. And vents will have, the coordinates. Well, actually, it's all of these, right? Yeah. It's just the coordinates. So, chords with distance, direction, and distance. And then our current position, so our offset, isize, right? And then we would just implement iterator for events. And then we would implement this. Remember, the item is going to be a coordinate. And I need to implement a method like into iter for this. Well, is there a trait for this, like into iter? Oh, there is. Okay, so into iter vents for that. Let's see what that looks like. Standard array collections. Oh, is there no generic one? Okay, so then I guess it's up to me to make my own. Function into iter, self goes into events. So it's basically events where that is self and offset is 0. That should be self, not size. All right, and then the next would be if offset is, well, if self.offset is greater than, because we won't include the final point, right? Self dot that dot distance, then none. Else, we want to compute the coordinate. Okay, it's going to be difficult to do. I already have a semicolon. I've already lost. Does that count? I'm going to say it doesn't count. Something tells me the hash map might be slowing your implementation down. How'd you get that profiling? I'm curious how you got it profiled. I can profile mine and see what I get. And can you improve a hash map by pre-allocating its storage? from Intel VTune. I don't know this. I'm going to have semicolons in here. It's unavoidable, right? So let position equal, and this is where I got to take the body of what we used to have here, right? This stuff. So it would be, instead of this, it's a chord where X is self, what's this entire thing, dot chords dot start dot X plus this whole thing again, distant direction dot X times self dot offset. Wow, that's quite a load. And then Y here and here and here. We're going to end up returning some position, but before we do, we want to do self offset plus equal 1. Okay, what did I get wrong here? Mismatch types. That's an eye size. That's also an eye size. Okay, what did I do wrong then? Why is it telling me that? Why did it find a unit? X and Y. Oh, plus equal. It should just be plus. There we go. That's the position to report. We add one to the offset and return some position. But when we go past there, there's no more. Okay, so now given that we buttoned away our semicolons, right? I can, with this fold, or unwrap finally, and then fold. With points, I can take a, well, I have to do iter, into iter. But I can take a position and do that. And then I can get rid of this let and this final thing there. What's wrong with, oh, this needs to be mutable. Oh no, we have a semicolon. One semicolon. How do I get rid of that semicolon? Inside this fold, what do we do to get rid of this? I think what I need is I need a function that will, this is a tough one. The entry functions, the entry function should be pretty fast though. I mean, yeah, you could just use a custom data structure because the grid is pretty small, right? At least in the test grid, it was just 9 by 9. So you can just make an array of 81, and then you just add you add x and y times 9, and that's your position in the vector. That'll be pretty fast compared to hashing it. But how do I get rid of that semicolon? You know, probably the solution is not to use fold, but to use what is it? Reduce? But how does reduce work again? Oh, it takes two adjacent items and reduces them? Which means like we'd have to put the hash map, the points in there to begin with. I don't like this. I don't know. I can't think of a way. So before abandoning this, let me try to take out as much of this, and we should be able to just have one fold, right? So the idea would be to move all of this outside, actually. The split once needs to be in a map, though. Like that, right? Unwrap. Okay. And then we don't need this unwrap out here. And then this goes here. Right? And then like that. Ooh. Wait, what? Position is a coordinate. Why did it find a coordinate with the direction and distance there? What did I do wrong there? Swapping to a vector dropped your runtimes from 77 milliseconds. So there you go. Yeah, that's usually the answer, right? For where you know the space of your keys, you can just drop it to a vector or an array, right? Okay, what's wrong here? Why does it say found a struct coordinates with direction and distance there? I am stumped. Is it just Rust Analyzer? Let's see. Mismatched types. It thinks that that's the wrong type. I think it's this one that's wrong. It says it's a chord, but it's not. So no, but this into iter should have done it. I think I see what's going on. I think I have to iterate. I have to map it. Shoot. This is turning them. What is this? What is that type? Let x equal that. And then x dot. What is x? Unknown. Okay. Can I say that I want a vents out of that? No. Okay. Let me think about one step at a time. So we have our input, we have the lines out of it, we map the lines to split, so we have an iterator where each item is the left and the right, And then we map that to some coordinates. So we have an iterator of coordinates. Then we add the delta. Then we filter out the non-diagonals. Then we add the distance. Then we turn the delta into a distance. Then we add the direction to that. Oh, I forgot to map it into something, right? Oh, I have to. I see. I have to do a map and then a what do they call it? Flatten. I have to do a flat map. So something like map in the type name into iter and then flatten. This one? And then flatten. Like that. There we go. Oh, except for I have a bug up here. It didn't like that because chords got moved. Shoot. Well, I can just make chords a copy type. It's sort of cheating, but we can do that, right? And then I never needed mark fence, did I? I never needed that because I ended up just doing them here. Oh, was that my thought to get rid of this semicolon? We actually never needed it. Okay. So I'm down to one semicolon and it's vertical, which is nice. I don't like the fact that I'm having to invent these types to hold intermediate values though. Yeah, just make the chords copy. There's got to be a way to accumulate things into a hash map without this semicolon here. What would that be? Ultimately, fold needs the expression to evaluate to the accumulator, and entry gives me or default gives me a mutable. How come it says unknown here? Did I just break it? Is it too deep? It's giving me a mutable reference, right? So the only thing I can do with it really is put it into a statement and mutate it. That's what this is doing, the plus equal 1. I think I know what I can do. I can make a function that does this. So, in fact, I can make a function that's intended to be used with fold is what I can do. Function fold into, what are we calling it? Fold into grid. So the first thing is the accumulator, which is this hash map of coordinates, this thing. So this is grid. And the second argument is the position. So position as a chord, and it outputs that grid again. And then here we can just put this in here. Only I called it points for some reason outside. Mutable. And then we can just pass this directly instead of having a lambda. There we go. I got rid of all the semicolons. Be sure to break it. It's gonna not work, right? No, it works. Of course it works. I had no doubt. So, this is as close as I can get to no semicolons. It's to have a bunch of intermediate types that hold, the intermediate steps of our data, and to hide away a semicolon inside of a function here. Didn't I hide another semicolon somewhere? Oh yeah, I hid one here inside of to chords. I don't need that. I can get rid of that semicolon. I can just do a map and then an unwrap outside, right? So map X and Y to chords and then unwrap. Get rid of the let. There we go. I fixed it. No semicolons. And I have one here too, unfortunately. And one here. But this is very contrived. I need to ask Musen if that counts. Or do I have to make it so that even the functions I write can't have semicolons? I don't know how to do this without this semicolon here, though. Because we're really needing to do two separate things. We're needing to mutate an entry to a hash map and then return the hash map itself. Does it count if you hide it? No? Yeah, I guess. So then we did it. If I turn off the inlay hints, it looks a little bit more obscure, but maybe better. And this can be flat map, right? And I could probably combine these two. I kept those separate to get rid of a semicolon between them, right? Because this distance needed to be used twice. And I didn't want to have to calculate it twice. So I calculated it once, put it into a new type, and then took it out of the new type to use it 3 times, basically. I guess we'll just keep it. And probably I can combine these two with a filter map. So filter map, if, I don't need a parentheses, then 2 chords on it with the sum in front. Actually, we know we can take this and do a then on it, right? Then what does the function take again? Oh, it takes nothing. So I have to do this, right? I think. And then I drop that one. Okay, it's a little bit better. Make sure I still get the right answer. All right. I can't think of how to chew it down any more than this. Looks like you got stuck somewhere. Uh-oh. Where did you get stuck? Hold on. What was your chat? The last chat before that? Ugh. What happened? Oh, it was like over an hour and a half ago. Are you still working on the problem, Sure Shock? Yeah, I'm just trying to do my solution down with no semicolons. Actually, now that I have this, part 2 is the same, only we remove a step, right? It was just oh, but there's this extra diagonal we have to take care of. So it's, instead of a filter map, it's just map, and then I remove this, I just say to distance, right? But we have to be careful about the distance calculation. Actually, I could just build that into this up here, right? Yeah, I can. Why don't I just do that? I have to put that in place of dx, and I have to put this in place of dy, but it's not that much worse. Okay, what's... Oh, yeah, and then just drop the rest of this junk, right? Yeah, and then run test part 2. Yeah, okay, cool. So then, and my part 1 still works? Cool. So that looks really nice and compact, but almost impossible to understand. I guess unless my names help. I guess the names sort of help. It's like we have lines, we split it and map it to coordinates, and then we, through a series of maps, we're adding the delta, we're converting the delta to distance, then the distance, and we're adding the direction to it, and then we're putting it into an iterator. Actually, let's rename this. Well, that's the convention, is iter, but really it's not iterating the coordinates. It's, let's say it's walk vents, or walk, I guess. Walk start to end. That's a better name, right? So yeah, so then we're walking from the start to the end, and we're folding all those positions into a grid, and then we're iterating all the grid positions and filtering out anything, or we're only including the ones where the count is greater than 1 and counting them. Okay, so actually this is pretty readable, I think, with the names. DXDY reminds you of calculus. What a nightmare. I'm going to report me for torture via math. It's only a little bit of math, and I hid it away, so you don't see. So just look at my solution. No math. All the evil is hidden away inside of these mapping functions. But the hack, so to speak, is this thing. This is how we deal with if we're on a diagonal or not. There's a different factor in the division to figure out the distance of our travel from start to finish. But the other stuff is pretty straightforward, right? I use the word delta whenever I talk about like the vector you have to follow from one place to another, and it's usually the end minus the start, right? And we're just doing it in each dimension. Hey, did I get rid of the dx's actually? So there's no more dx's. Yeah, see, I fixed it. GZBAku. No more dxdy. It's no longer a nightmare. Yeah, there's no semicolons in my part 1 or part 2. There's a semicolon here when I fold it into the grid. There's semicolons here in my iterator implementation. 3 of them. And there's semicolons that are required when we pull in hash map. I guess we can remove this, and where we actually use hash map, we can just do it fully qualified, right? There. That's the price of not having a semicolon at the top. I think here we can get away with just doing new, right? Well, first, let's fully qualify it. But can I just do new here? Will it figure it out? Yeah, it figures it out. We don't need the turbofish anymore. Oops, I didn't mean to do that. I meant to do qualify. We don't need the turbofish because it uses type inference to figure out the type. Can we split iterator into tuples of... Yeah, that's split once. Is that what you mean? Like map into split once? That's what that does. So it gives you an option with what's on the left and what's on the right if it found that delimiter, and it'll do it on the first delimiter. If there's multiples, it'll pick the first one. Yeah, I think Musen told me about that like 1 or 2 streams ago, and I had known it before, but I had forgotten. Yeah, that happens. Okay, I actually think this was worthwhile reducing it to a function chain, because each step sort of clearly marks like what data state is in at each point, and it's all captured by these structures, right? First we have single coordinate, and then we have two of them, a start and the end, and then we added on a delta, which is like how you get from the start to the end, and then we added on the distance, and then we dropped the distance, dropped the delta in favor of a direction vector and the distance, and then we defined how we're going to iterate that by here's how you start the iteration at offset 0, and then every time you move next, we're incrementing the offset, and then the position is calculated as the start plus the direction times the offset. And we hid away, because 2 chords is called twice down here, we hid it away in its own function. All right, there's 3 of them, right? First we go from a string to a coordinate by splitting once on the comma, mapping them to the x and y. We have to trim away extra stuff, parse, and then crash if it's not a number, and then crash if we couldn't split. Actually, this can be moved, right? No, it can't. It can't be moved because map works with option. Unwrap says it had better be something. Right, so that unwrap has to be last. And then, yeah, to get the delta from the coordinates, you just subtract the start from the end. Yeah. All right, I'm happy with this. I think I'm going to call it here. I won't be able to stream on time day 6, but I'll be able to catch up on day 7. I'll do day 6 and day 7 on Monday, I think. Actually, no. It's going to be weird because I can't stream at this time for the next several days. So I'll probably be doing like the previous day, like between 18 and 24 hours after. So I won't be able to do the next few puzzles on time. But let's see if anyone else is doing Advent to Code. We can go raid them. I haven't had much luck with this so far. It doesn't look like anyone's doing Advent of Code. Okay, well, we'll just call it. So I'll be back tomorrow sometime or the next day. Actually, probably the next day. I hope you enjoyed Advent of Code. We'll be doing this again the next few days. See you then. Thanks for watching. Bye. Bye-bye. Oh, hold on. Where is X is doing it? Okay, let's rate where is X. Where is X? Okay, good. Because Where is X rated us yesterday. We'll rate them back. Sounds good to me. So yeah, again, bye-bye. Enjoy Where is X's stream. See ya.